Okay. This is page 68. I need you to be fully attentive. This is definitely one of those units that gets used multiple times in future math classes. You need to make sure that you're paying attention and you're also thinking, right? You're not just blindly copying down what you see. Can you lock that in your face? Just push the button.
My head's broken.
I mean, I have migraine.
My head.
We're looking at Introductory to Trig.
Yes.
Introductory to Trig. We're going to jump around. This paper covers all of the introduction part of it. We're going to jump around in a way that I feel like is where most students benefit the most from it. All right, so looking at it. First of all, what is the word trigonometry? That's how you say it. It's called trigonometry. If you have a highlighter, it would be helpful here today.
Triangle.
Okay, say it with me. Trig, which is trig is the abbreviated word for trigonometry. It is the study of right triangles. It's the study of right triangles. There are 3 trig formulas that we're going to learn. They are sine, cosine, and tangent. Sine, cosine, and tangent.
What the heck?
So sine, cosine, and tangent can only be used with right triangles for right now until you get to higher level math, and then you'll learn what's called law of cosines and law of sines. But for right now, they are only used with right triangles. There is something very important, and that is that you remember to put your calculator in degree mode. If your calculator is not in degree mode, you will get the wrong answer. It will be such a wrong answer, it won't make sense, it's not possible, which should be a red flag that you forgot to change the mode of your calculator. How do you change the mode of your calculator? Please look at your calculator and find the button that says mode. Then find the word that says degree. Highlight it, hit enter so it will select it, and then you can just get out of there. Yeah, you just go over it until it's highlighted. Some of them are already in degree mode.
I was.
Wait, how do you what?
Guys, hit the mode button. It's at the top. Next to second. You move the cursor to it and hit enter. Yeah, and then you just can get out of it and clear it. You don't want to highlight it. Oh, you would change it to the other mode. Like there's only 2
Wait,
options.
do we need to change it back?
No, it needs to be in degree. Okay, your calculator should be in degree mode. If it's not, you're going to get the wrong answer, and I just told you how to change it. Hit the mode button. You arrow down to where it says degree. Move the cursor to where degree is flashing. Hit enter. Then you can clear out of that. There is something else you need to pick up on, and that is this little symbol right here. It looks like a slanted O with a line through it, and that is theta. Looks like an O with a line through it, but it is the word theta. I did not mispronounce it. That is a Greek letter of the alphabet, like alpha, beta, omega, gamma, sigma, nu, phi, epsilon,
Oh,
theta. Theta is a Greek letter of the alphabet. We are leveling up to higher level math. You are no longer going to have an X inside the triangle. It's going to be theta.
Yay.
It has no numerical value. It is a fancy X, which stands for a missing angle measure. It's when you don't know an angle measure, instead of putting an X, you're going to see a theta. Look, y'all. Instead of X degrees, no more. It's going to say theta. That's it. And it means, hey, that angle's missing. I don't know what it is. It's a variable. Okay? Here are your three trig. Here are your three trig functions. Right here. Sine of theta, the way you read it. Sine, that is not sin, it's sine. It's a long I. Please don't call it sin. It's a sin to call it sin, okay? Because that means you don't know what you're talking about. Sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. Tangent of theta is equal to opposite over adjacent. Those are your three trig formulas. It would make your life easier if you can memorize them. I will show you a technique to do that tomorrow. Those are your three trig formulas that we're going to use. Look at your graphing calculator. Find the three buttons that say sine, cosine, tangent. You will now start using those buttons. Okay?
That's what those were for.
Yep. Now, I have seen before, theta is the most common Greek letter used for missing angle measures. There are three more Greek letters that I have also seen, and we will see them at some point, but they don't appear every problem. Come right here. Let's draw an arrow. Let's draw an arrow, and we're going to say also. Now you got to watch what I'm drawing. Alpha, which looks like the little fish symbol. Theta looks like a slanted V with a tail. And then our other one is gamma, which I think we get in one problem. It looks like a Y with like a little hook. That is gamma. I'm not asking you to memorize what they are called. You do need to memorize the theta one. Alpha and beta are pretty self-explanatory. You should know those.
Is it supposed to be like longer?
It's a Y. It's like a Y.
No,
And
not
yes,
that.
beta has a tail. Yes. Okay, shh.
Theta has a tail.
Okay, before we go to the top of this sheet, I want you to direct your attention right here at this triangle. This one. What type of triangle is this?
Right
It's a right triangle. What did I tell you to do every time you have a right triangle?
Every time you have a right triangle.
What did I tell you to draw?
An
An arrow from the
Right.
right angle to the hypotenuse. And then that is the hypotenuse every time. Now, the new part is, after you label your hypotenuse, you're going to now have on your picture theta, which means label your hypotenuse, then direct your attention to this angle right here. You can either circle the corner, you can circle it, or you can draw an asterisk. You can draw an asterisk to say, okay, I'm focusing my attention from this angle right here. Now, from that angle, what would be considered opposite?
Three.
Opposite's going to be the side farthest away. If I trace it, did I touch that angle? No, so this is opposite. Which leaves adjacent to be the last one you label. If I trace it, did I touch it? Yes, so this is adjacent.
So you wouldn't label
So adjacent would be 4.
5 can't be adjacent because it's the hypotenuse. Which is why you want to label the hypotenuse first, because it supersedes the others.
So you really only have to come down to, and then the third one.
Right. And I always label in the order of hypotenuse, opposite, and then adjacent's the last one. Okay, so coming to this one right here. Let me erase this. Coming to this. Go back to the top. Labeling sides of a right triangle. Label these sides as opposite, adjacent, or hypotenuse. So I know that it's kind of hard to see. That's a 3, that is a 4, and that is a 5.
It's the same thing we just did.
Okay, I know that one. I know. I did it on purpose. Alright, draw an arrow from the right angle to the hypotenuse. So that's 5. Now, go to the angle that has theta. Either circle it or put an asterisk. Do whatever you need to. I want to see something in that corner. Now, from there, label the opposite, then label the adjacent. Do the other one. In fact, go ahead and finish A through D.
Is it the same thing?
What?
Like that's also
It's
right.
the same thing.
Wait, can it be a square?
Yeah, it can be. Yeah, that's the side of the side. That's the length of the side. You should be done with the second one. You're drawing an arrow from the right angle to the hypotenuse. So it's square root 5. Then you go to the angle marked theta. Put an asterisk. So what would be opposite? Opposite of theta.
No, I'm sorry. I wasn't looking at
Remember, the right angle is only there to show you where the hypotenuse is. Then you move to theta. Are you trying?
Yeah.
On your paper? But I want you to do these too. So, opposite would be 2, and adjacent would be 1. So 1A through D. Label each side of the triangles below as opposite, adjacent, or hypotenuse based on theta. Before you label anything based on theta, what are you supposed to label?
Find the hypotenuse.
Draw an arrow from the right angle to the hypotenuse. Label it as hypotenuse. Then go to theta. Focus your attention from here. What's opposite? Left or up? The opposite would be left here, and then this would be adjacent. Finish B, C, and D. So right here, okay, this is the hypotenuse. This would be opposite. This would be adjacent. Are y'all getting this right?
Yes.
Because if you're not going to be able to do this. Did you get them?
Man.
Okay, go to the middle of your paper. Here's where the new stuff comes in. If I tell you to set up a trig function, then what I'm saying is you should write either sine, cosine, or tangent. The angle measure equals a fraction bar, and you'll notice that the fraction is composed of the sides of the triangle. Do you see that? Theta represents inside the triangle, the angle. The fraction represents 2 of the 3 sides of the triangle. So I want you to come right here and make a note in quotes. You're going to hear me say this. If I say set up your trig function, you should be writing right now. If I say set up your trig function, then I mean you write which trig you're using. I can't write all 3 of them, but it's either sine, cosine, or tangent. It's an angle equals fraction bar, and it's a side over a side, right? Every time. So this entire paper covers like 1, 2, 3, 4, 5 different types of questions based on trig. 5 different ways that I could give you a trig question. They are compartmentalized by the bold. So I don't know if you want to highlight that part. But if I just say calculate, this means go to your calculator and enter the trig value, round your answer to the nearest 10,000ths. Now, your previous problems, you've always rounded to the nearest 10th or 100th, right?
Yeah.
You rarely go to the nearest 10,000ths. We're going to the nearest 10,000ths because trig actually revolves around something called the trig tables. Back before graphing calculators, they had to use trig tables to answer these problems. Now, when I was in high school, we had graphing calculators. I'm not that old. But our teacher did make us learn how to use a trig table to read it. And then, of course, we had our graphing calculators to check our answers. I am not making you do that. However, you do need to know how to round correctly. If you forgot how to round, you always ask yourself, how many zeros are in what it's telling you to round to? So, in the number 10,000ths, which means 10,000, how many zeros are there? There's 4. So there's 4 zeros, which means 4 decimal places, which means check the 5th number. Check the 5th number after the decimal. Right? And if it's 5 or higher, that's when you round up. Y'all with me? Okay, so we are only going to cover tangent. I've learned that this is a lot easier if you learn with tangent first, and then sine and cosine kind of fall into place. So we're just going to write tangent. Did you write that down? I don't think you did, Trish. You got too comfortable. No, this part right here. You write that down. All right, so we're looking at just the tangent problems. This says calculate tan of 87 degrees. That means you go to your calculator. You would push the tan button, tan, you would enter 87 because what mode are we in? Degrees. I need everybody to do this. I can't tell you how many people just sit there and they don't try and then they're
Wait, so we
confused.
have to put the.
It's just good habit. You don't have to, but it's good practice for when we get to something where you're solving. You're going to enter it and you're going to get the decimal. Now you have to round it. We're checking the fifth number after the decimal, which is a 3. Never mind the 6, 6, and the 9. The fifth number is a 3. Is that enough?
No.
No, so the fourth number stays the same. So it's 19.0811. All right, we're moving around because we're only doing tangent today. The next type of problem would be if I asked you to simply set it up. If I asked you to tell me the trig function from a certain angle, what would it look like? Okay, so here's our picture. Here's the 72-degree angle. This says from 72, which means pretend like you're standing right here. First of all, there's the right angle, so this is the what? Hypotenuse. Now, if I'm standing here, right, you got to set up your trig function. And we're doing what today? Tan. All right, so set it up. Tan. What's the angle they told me to use? 72 equals fraction bar. Don't write big here because we got tomorrow we'll do sine and cosine. All right, what's the formula for tangent? From the 72. So imagine standing here. What's opposite? 55. What's adjacent? So that's what fills in the fraction. This was opposite, and this was adjacent. Say it again. You can't type that in the calculator. We're not typing anything in. They just want you to set it up, which means just write. Thank you. Appreciate it. They just want you to set up the equation. No, we're not solving. There's no x. You're not solving. All right, now write it from 18 degrees. So we're just doing tangent. Tangent, what angle? In this case, 18 equals fraction bar. It's opposite of 18. So focus, pretend like you're standing at the angle 18. 27 is opposite, and 55 is adjacent. Now there is something to take note of here. You will never calculate the trig of a right angle, which means, red means wrong. You will never set it up like tan 90 degrees equals something. That is absolutely never going to happen. And that's because the 90, remember, opposite of it is the hypotenuse. The formulas don't work if you were standing at a 90-degree angle. Okay? It's always the two acute angles. All right, go to the back. Here's a different type of problem. What if I said draw and label? Okay, jump to 7. When I give you a trig ratio, I have just told you two sides of a right triangle based on the formula. What was the formula for tangent? Opposite over. Sure. Opposite over adjacent. Okay. Number 7. We're skipping to tangent. Go to 7. We're going to draw our right triangle. Let's draw it all the same so we don't mess up, or so we don't have different answers. Draw your right triangle. We're going to label A as one of the acute angles. I'm going to put mine down here. Now, if I put my angle A down there, that's going to change, or that's going to dictate where the 17 and the 15 go. If you put your angle A up here, yours would be opposite of mine. All right.
Good afternoon,
What's
your
the
best
formula?
message for today.
It's
Best 114, one double up on
it's opposite over adjacent.
61.
Okay, hold on. That's not 4 minutes. I'll wait
Best
till she's done.
111 will be 55.
Okay, the next question is saying, using this picture, write the trig ratio, which means write the fraction for each of them. The fraction is always a side over a side, and we're only doing which trig function today? Tangent. So what are our two sides we're looking at? Look at the formula. Opposite and adjacent. From the angle they tell you to focus on. Alright, so tan would be number 13. So from angle P, what would opposite of P be?
3.
And then what would adjacent to P be? 4. Alright, now from angle Q, hope y'all are looking, because this goes so quick, because it's so simple, that you're going to have to make sure you're looking and thinking while I'm going through it. Looking at the next one, tan of Q. What's opposite of Q? I'm up here. Hold on. Opposite of Q. 4. Adjacent to Q. 3. So it's 4/3. Okay, coming to the next section. Exact same type of question. It says, give the value of each trig ratio, which means tell me the fraction. Remember, ratio is a fancy word for fraction. We're doing just tangent. Look at 19. 19 says, focus on angle P. Freezing. So glad it's there. From angle P, what is opposite?
5.
I need you to say I don't know.
I don't know.
Okay, if you look at it, we don't know this, do we? Okay, go back to the very first lesson from this unit. What did we learn to find the missing side of a right triangle when you know two sides? The Pythagorean theorem. So you would use that here. What part would go in place of C? 13 would go in place of C. If you think back to that chart with the Pythagorean triples, you might remember that 5, 12, 13 was a Pythagorean triple. Now, if you don't memorize that, that's fine. You would do 13 squared, and you would have 12 squared, and you would subtract it, and then square root it, and you're still going to get 5. So this right here is 5. Now I can set up the ratio. So opposite of P is 5, adjacent, 12. Now we're going to go to 21. Opposite of Q,
12.
and adjacent.
5.
What do you notice about the tangent of the two acute angles from the same triangle? They're just reciprocals. They're the flipped fractions. And that's because you're going to the other angle, and now the opposite and the adjacent have swapped positions. Okay, now the last part, which is the part that gets used the most. Look at number 22. First of all, let me box this in, because this is the title of this section. This is saying, hey, you could also use trig to find a missing side length if you didn't know it. Look at number 22. Can I use the Pythagorean theorem?
No.
Why can I not use the Pythagorean theorem? There you go. So what is the point of trig? One of the purposes is, if I have a right triangle with a side missing, and I don't know another side as well, I can't use Pythagorean theorem. Enter trig. Trig lets you find that side where you still have to know at least two things. Whether it's an angle in a side or two sides, you've got to know something at least to start with. But here is what I'm looking for. I don't know it. I can use tangent here. Draw an arrow to the hypotenuse just to remind yourself where that is. Then come over here to the angle they have given you Do something to draw your attention to it. If I walk around your desk and I see on your paper, that, and you're getting it wrong, then the first thing I'm going to say to you is, why are you not doing what I did on the board? Because that's what's going to help you get to the answer. So make sure on your paper, whatever I'm doing, you're doing as well, okay? So draw your arrow to the hypotenuse, come over here to the acute angle, accent it somehow, whether it's circle it, whether it's draw a little asterisk right here, whatever you need to do. Just say, okay, I'm focusing my attention from there. If you have only one missing side of a right triangle, then you can use the Pythagorean theorem to find the missing side. But if you have more than one missing side, you can't use the Pythagorean theorem. Instead, you would use trig, which is what we're about to do. You can use trig. Read the directions. Find the value of the missing side using trig. Round your answer to the nearest what? 10, which means how many zeros? 1 0, which means check the second number. Okay, the first step to solving with trig is set up your trig function. Okay, go back to the front of your paper. Go back to the front. Setting up your trig function meant what? It meant writing the formula. Writing exactly what the formula is. We're doing tangent today, right? So it'd be tangent, the angle measure, equals fraction bar, and then fill in the formula. So going back to the back. So I'm going to set it up. Tangent. What's the angle measure? Equals fraction bar. What's the formula for tangent? Opposite over adjacent. What's opposite?
X,
What's adjacent?
10.
Okay, you set it up. Does everyone understand how I set it up? Now, the idea is to have x by itself. The first thing you're going to do is, it's kind of like a cross multiplying. This is understood to be, don't write this part. This is understood to be over 1 every time. So when I cross multiply that 1, does it change that? No. But when I cross multiply this, it is going to affect my problem. Now here's the only thing. Now I showed you that because I want you to know that what I'm fixing to write is the product of cross multiplying. But because this was a 1, it never changes that top part. So what I have always taught is cross multiply the denominator, but it's going to go over here to the front because that is protected. That tan 27, that is an entity that you can't break up. You don't shove the 10 in there and say 270 because now you just busted the triangle, right? That 27 degrees is an angle. This 10 is not an angle. It's a side. They are not the same. So the 10 has to multiply to the front. Why do I not want to put it at the end? Because then it would look like 2,710, which again, busts the triangle. So I call this an elbow arrow. I call it an elbow arrow. I've taught it, and it has helped people to remember, okay, that's got to come over here to the front. And it's by multiplication, by the way, when you do that. So what do you get? You get 10 times tan 27 equals x. Now, is x by itself? Now? Yes, which means you're ready to go to your calculator. So go to your calculator. 10 tan 27. Enter. Now it said go to the nearest 10.
5.1.
You get 5.1.
So X equals 5.1.
Yeah.
And this?
Yep. Yeah.
My tan's doing something bad. It's doing tan power -1.
Well, then maybe they will send her home. Did she keep in the hall?
Do you have to multiply the 10 to the 10?
No. When you go and type it in your calculator, if you enter times 10, you'll notice you get the same answer as if you just write it side by side. The calculator understands it to be multiplication if you enter it the way I did right there. All right. Look at number 23. Draw an arrow to the hypotenuse. You will notice it's what? It's blank, right? Okay, then go to the acute angle, make an arc or something to draw your attention to it. And now we are solving for x. We're going to set up our trig function. What function are we using today?
We are
Tan.
using
We're using tangent today, so set it up. Tan angle measure equals fraction bar. In the fraction bar, go your two sides. Yes, it matters where you put them. How do you know where to put them? The formula for tan is opposite over adjacent. Opposite of what? Opposite of the 46. Why? That's why we drew our attention to the 46. So I'm going to put it on the board. I just want to make sure everybody tries it first. This is so important that you know how to do this. You want to talk about some easy grades? That would be this unit right here. If you'll just try and think, I promise you'll get it. And then you'll secure an easy quiz, an easy test. And it's going to come up again in Algebra 2, in Pre-Cal, Calc 1, and if you go any higher. All right, your trig function should have been tan angle measure equals fraction bar. What's opposite of 46?
7.
Okay, and what's adjacent?
X.
Okay, there's a reason this one looks a little different. What's the difference?
X is on the bottom.
The X is on the bottom. The good news is, whenever you're doing these problems, right, there's only two types of fractions you're going to get. X will be in top, which means it's short and sweet, or X is on the bottom, which means there's just one additional step you have to go. But this is it, right here. All right, so the first thing you do is you draw your elbow arrow of whatever's in the bottom of the fraction to the front. So it's going to be X times tan 46 equals 7. You feel like you need to go to the nurse?
No, I'll be fine.
I'm not worried about you.
No, I'll be fine. It's just a stomach bug.
Stop, dude.
He's got a scrimmage.
Stop talking about it. I'm gonna go off.
Is X by itself?
No.
What's attached to it?
Tan?
Always think of it as an entity.
And
Let me show you something that a technique that I used with my college math kids with stuff like this. This is, y'all know those wooden blocks kids play with?
Yeah.
The big old-fashioned wooden blocks? Think of this as a wooden block that has it painted on the front of it, which means wherever you move the word tan, the 46 goes with it. You know what I mean? It's a block. Okay, so now let me ask my question again. X is not by itself. What's in the way? Tan 46 is in the way. How's it attached?
It is multiplied.
It's multiplied. How do you move it? Okay, and if you will show your work, there's 3 people in here who I know can't stand showing work. You're going to need to show it a little bit on here Because if you get it wrong and you don't show your work, I can't tell you where you went wrong. But if you'll show your work, I know exactly where you went wrong. If you will show this right here, and you know to yourself that this is going to move by division, write it on both sides. That will cancel. That's what you type in your calculator right there. Because x is now by itself. You're going to type 7 divide tan 46. 7 divide tan 46. And you get 6.8.
So if the x ends up being on bottom, you divide, and if the x ends up being on top, you multiply.
Right.
This is really
Just wait, it's going to get easier.
easy.
Number 27. Go to 27. Draw an arrow to the hypotenuse. Draw an accent on your acute angle. Set up your trig function and solve it right now.
How do you know which ones are?
You're going to learn that answer after I teach you sine and cosine. Right now, I'm directing you to the tangent ones. Here.
61.6.
What we did right there.
I think you got an area what you're doing.
So
It's like you understand it better.
from here, what's
That's
opposite?
what I did that, but I don't think like Paul.
Yeah, well,
I'm just like-
No, opposite being farthest away, not touching X.
What?
I'm the one that's getting it.
You what?
Hey,
Did you get, okay, shh. Did you set it up like this?
Yes.
And?
Yes. No. Yes.
Cross multiply the denominator, elbow arrow it to the front, and that's what you go to your calculator and type in.
No, 61.6.
So everyone was right.
61.6 backwards is almost what Tom is right now.
Okay, you might think to yourself, 61.6 seems like a really big answer. Go to the picture, look at it. We said X is 61.6 here. What is this side? 20. What is the measure of the angle opposite of the 20? What is the measure of the angle opposite of side 20? You know enough to find it.
Oh, 90 plus 72
18.
is.
Say, continue it.
90 plus 72. So that's 16. 162. So
But what's the cap on triangles?
they all equal.
They add to 180. So this measures 18 degrees. Okay, so now put it into perspective. The 18-degree angle formed a 20 side length. So doesn't it make sense that the 72-degree angle is forming a 61 side length?
Yeah.
Now you can like wrap your mind around, okay, that actually makes sense. So if you do get an answer that feels weird, check it like that. All right, the sheet that you have in front of you is your practice assignment.
Sorry.
It's being passed back right now. This is your practice assignment.
Calm down.
here, partners.
We all.
Oh, wrong one. Hold on. I opened the wrong file. Y'all need to just stop for a
Is this
second.
page 69?
Yeah, this will be 69. We'll put it in our table of contents in a second. All right. Using tangent to solve for sides. This entire sheet is just tangent.
You already put it in.
Is it already in there? Okay. This entire sheet is just tangent. Go to the top of your paper. It says, what's the tangent ratio? And then I gave you a blank triangle. This is saying, if this was your triangle, and I said, tell me the tangent ratio for A, it would mean find the side opposite angle A and put it over the side adjacent to angle A, right? You're just copying the formula for tangent here.
Okay.
What if it was from angle B? It would be opposite angle B over what? Adjacent angle B. Now, numbers 1 and 2, you will notice there is no x because you're not solving anything, right? It says, tell me the. Yeah, it's on my purse in the corner. Okay. Notice that it doesn't ask for you to solve for x. It says find the value of tan angle x and tan angle y, and write your answer as a what? A fraction. So tan of x. Now, what should we label in our picture so we don't accidentally use it as one of our opposite or adjacent numbers? Let's label the hypotenuse. In this case, it would be what? 85. I'm going to come over here and write hypotenuse. And that, you notice, is never used in tangent. Tangent doesn't use the hypotenuse. All right, so what's the formula for tangent?
Opposite over adjacent.
Okay, what's opposite of x?
13.
What's adjacent?
84.
Done. Now do tan y. What's it gonna be?
84. 13.
Okay, what do you know about about the number 13? Starts with a P. It's a word in math that means it's only divisible. It's prime. It's only divisible by 1 in itself.
Almost at the level.
So, is there any way that 84 over 13 could reduce? No, because 13 won't go into 84. When you get to question 2, and you set your fraction up, you should notice your numbers are both even, which means will they reduce?
Yes.
Yes, and you do need to reduce it. There's a shortcut in your calculator that is called math frac.
Number 3.
3 on our page.
Oh, see, yeah, that's number 3 on our page.
I switched it. I forgot to print the new one. I'm sorry.
Okay.
I remember switching it last year and I forgot to reprint the new one. And that's because these two don't ask you to solve, they just ask for the fractions. The next one asks you to solve. So that was the difference. Yeah.
Okay, so math frac.
Your paper has your question 2 and 3 on your paper are switched.
Your answer.
So if you go to question 3 right now. Go to your question 3.
There.
All right, try it. You need to write tan of A and tan of B, and it needs to be reduced. Uppercase T is fine. I just don't.
You
is fine. I don't, but it doesn't matter.
What is math frac? What do you do with that?
Well, do you have your ratio for tan A?
Yeah.
What's your ratio for tan A?
40 over 42.
Okay, is 40 over 42 reducible?
Yes.
Well, what if you're bad with numbers and you don't know how to reduce it? You would type 40, divide 42, and then you're going to hit math, and the very first option says keep the fraction, and it will reduce it for you. You see that?
Oh. Yeah.
So this would be, I'm going to say, or 20 over 21.
Okay, I messed up.
Why is it doing that? You said, oh,
Depends on what angle. No, because this is the hypotenuse, this is never anything else.
you said
That's the hypotenuse is always the hypotenuse, and it can never be anything else. Which is why it's helpful to label it, because then you know, bam, there's the hypotenuse. Do what?
You said do 40 divided by 42, and then
Yeah.
hit math frac.
Yeah. What'd you get for the tan of B? Did you get 21 over 20?
That's all you have to do.
Because it just wants you to write the fraction. Now-
That sure is.
Well, yeah, because the only way y'all are going to get this is through repetition. All right, number 3 dives right into the whole solving. Setup number 3. Draw your arrow to the hypotenuse. Blank. Put an arc or something to draw your attention on the acute angle. Now set up your trig function. Tan. What goes next?
25.
I'm on number 3. Are you on 4? I'm on number.
Or number 2. Now
I'm
you're
on number 2. I'm sorry. Yeah. I'm gonna reprint that for next block because that's what brought the nuts. But I'm saying, what goes next? There you go. Okay. Don't ever confuse this, y'all. That is always an angle. It's always an angle that's written next to tan. It's never a side. Okay, the formula is opposite over adjacent, so you get x over 15. Cross multiply it to the front. Go to your calculator.
8. It's 7.9, but
It's 7.97.
Okay, so it's 8. Let's do the next one. This is going to be one of each, where the x is in the top or it's in the bottom. And then I'm turning you loose to finish it. Alright, we got our hypotenuse right here. Here's our acute angle. Set it up. Tan, angle measure, equals fraction bar. What's opposite 25? What's adjacent? Okay, cross multiply the denominator to the front. Show your work, and then you'll know exactly what to type in the calculator. X is not by itself. I've got to move this by division to both sides. Or I'm moving it to the other side. I'm dividing on both sides. And that's what you type in your calculator.
68.7. No, 6.
Yeah, 6, okay. And you might think again that that's a really big number, but if you look at the picture, one of the side links was 32. So it actually makes sense. Now, I want you working by yourself. I don't want you with a partner yet. I'm going to let you go to a partner after a little bit. But I want everybody working on your own. When you go to the back, the top 3 questions at the back are where they're asking you once again to just show me the fraction. You're not solving. The decimal will come from actually typing the fraction in your calculator. So like if you went back to like right here, the fraction answer would be 13 over 84. the decimal answer would be 13,584, and then you would write it.
So rounded to 4 places.
So you would check the fifth number. So in that case, it would bump that up.
0.155.
155, or no, 1548. If it said round to, let me,
My brain is freezing.
if it says round to 4 decimal places, you would check the fifth number, and the fifth number in my case is higher,
Yes, that's what you
so it would bump the fourth number
I
up.
couldn't see that.
Yeah. But anyways, that's how you would get the decimal part in the back.
Gotcha.